Alright, 49 is fun because you get to use calculus. It's asking for what value of x. So look, if you look at the figure 15-44, what value of x will give the least period for this physical pendulum? And so that should have, sirens going off in your head. Ding, ding, ding. Least value. Probably got to take the derivative, set it equal to 0, and that's what we got to do. So first off, it's a physical pendulum, so we're trying to find the least value of the period. What is the period of a physical pendulum? It is 2 pi square root of I over mg what is that? mg. What's that? I'm going to use H because the book uses it as I hang my head in defeat my inability to make up my own letter. Anyway, we want to minimize the period, and for a value of x. Well, where is x in here? Oh my god, it's right here. Hey, I'm saved. I'm saved. I'm going to do it right now before my head explodes. Your head explode. Oh my god, I gotta show you guys something. Pause. Have you ever heard of Homestar Runner? If not, you should have. Strong bad zone. Your head explode. Anyway, yeah, uh, love that site. Um, you could spend hundreds of hours of your life on that site. It's just amazing. Be very careful. Very, very careful. Shouldn't have showed you that. Anyway, my head's not going to explode because I've replaced H with X and life is good. Yeah. Now, what is the. This is a pendulum. This is a rod. And, rod has a moment of inertia of 1/12 ml squared plus m. Now, the distance from the pivot to the center of mass is x. Yay, x squared. So that actually is what we're going to put up in here. 2 pi square root of 1/12 ml squared plus mx squared over mgx. And you're probably already thinking, we got to take the derivative of this with respect to x. What? I'm going to do it out because, well, it's kind of fun or something. But first, let's simplify. M's cancel. And this becomes 2 pi. I'm going to rewrite the square root as to the 1/2 power. And this becomes, I'm going to split this up. L squared over 12gx plus x over g, because this x cancels with one of these x's, all raised to the 1/2 power. And now, oh, actually, this is different than I did it, because I used the, actually, so, yeah, I'm going to do this differently. I used the quotient rule, which now looks like I don't have to because of, this is L squared over 12g x to the negative 1 plus 1 over g times x, all to the 1/2. So we want to minimize t of x. So that happens when the derivative of t of x equals 0. So we gotta take the derivative of this. And so first we bring the half out to the front. 2 pi times, I'm gonna just call it crap, to the 1/2, negative 1/2, right? Because you gotta subtract 1, bring the exponent to the front, subtract 1, times the derivative of the inside. And so the derivative of this is negative L squared over 12g x to the negative 2 plus 1 over g, and distribute, those cancel, equals pi square root of, I'm going to write the crap out now, L squared over 12g x to the negative 1 plus x over g times negative L squared over 12gx squared plus 1 over g equals 0. Now, this has two solutions. Like if you divide this, so if you divide, well, pi can go just disappear because you divide pi on both sides. But if you divide this over, it cancels, and you get this term equals 0. Or if you divide this term over, that cancels, and you get this equals 0. And they give you the same. They give you this. It turns out I did them both. They give you the same value, except one of them, although that might be different now in this one, but one of them took the square root of a negative of that same value. So that was that one. So I'm just gonna cancel this one out, divide by 0, and then so this equals essentially this equals 0 now. And again, one more time, I just divided these over and then 0 canceled them out. So this essentially becomes 1 over g equals L squared over, because I'm adding this to both sides, L squared over 12g x squared. Bring the x squared over, g's cancel, x squared equals L squared over 12, x equals L over the square root of 12, which is, we know L, right? Did they give us L? They gave us L is 1.85 meters. So this is 1.85 over the square root of 12, which is 0.534 meters. That was cool, and it worked out this way too. Yeah, I when I did this, I left this all. I didn't simplify this. I just left it like this. So I did the quotient rule, Heidi ho, hody hi ho ho, crap. Same thing. This, I guess, is a little more straightforward. That's part A. What's part B? Part B is to find the actual period with that x. So now we just essentially take this value of x, stick it back up into here, and here, solve for all this, and you get period equals 2.07 seconds. So that's the shortest period. The longest would be longer than 2 seconds. 1/1000, 2/1000. Sort of a long swing. Anyway, yeah, that was a cool problem. And one more to go, number 57. And I'm not going to do all of 57 because the part B is actually not really something we're concerned with. So, goodbye.